on stream at least. Alright, so there you are. Here's the stream. Let's make sure it's working. You are. Alright, cool. I think it's good. Let's do a quick sound test. Get the chat going. I can pause this. Did it go up quick today? No, not yet. It's funny. It'll go live, but it'll have, I don't know, like a 2-minute, 1-minute delay before it finally shows up for everybody else. Like, I get quick access for some reason. My broadcast program just lets me click right onto it.
Nope, not yet. Refresh again.
I could send you the link, but I feel like that would give us a false sense of like when it's up for students, so. Oh, just wait a minute.
No, I still don't have it.
Is the mouse? Where is the mouse on the screen? Oh, that's interesting. The mouse goes over your window. And then it comes up in the stream. Oh, well.
No, it's still not there yet.
Interesting. I said it to public. Oh, Brady's on. Yeah, happy Earth Day. You can see right here. Definitely changed the background a little bit.
No, I still can't get on. I'm gonna get off and see what happens.
I'm gonna do a research for. Still doesn't say I'm live. I guess only Brady. Oh nope, here we go.
Oh look, because I just got off. That's fine.
Oh, you're good. Sound check on both of us seems solid. Mr. Brady Parks, welcome back. 100% attendance. Was delayed like 3 minutes.
Yep, I'm just getting on now. It's like loading up.
Cool. Well, at least it is up and running. We should have other people joining up. Yeah, we didn't start streaming until a minute or two after 11, so that's why it might not have come up exactly on 11. We were having some little difficulties here and there, and plus wanted to, get the Earth background going here.
Yes. It's all about the Earth today.
Oh yeah. Nice sunny day, a little bit of a breeze. Kind of cold though.
Yeah, it's only like 40 degrees.
Yeah. Yeah, 42 and mostly cloudy, but you'll see some golden rays coming down. It will get cloudier as we progress through the day, I believe. Oh no, that's tomorrow's forecast. It'll stay kind of cloudy until 4 or 5, in which case it'll be setting pretty soon. But tomorrow is just going to be a cloudy day, and then rain all night. Well, that's kind of good. I like rain at night.
I just don't want any more rain. I'm tired of the rain. I want to be outside.
Really? I want it to be 75, no humidity, gorgeous days. That's what I want.
Yes, I'm with you.
That would be nice. Go sit out on the deck, have some iced tea, read a book, get a tan, because like a ghost right now.
I want to be able to maybe sit outside and do this kind of stuff have a different scenery.
Oh, I unfortunately can't do that with my setup, but
No, you
I mean,
can't.
I can always put up a different picture behind me. I could take a picture of my backyard, pretend I'm there. So let's see, how many people we got? We have 5. And that's probably, again, just like you, me, and Brady. Because I've got, what, 2 up myself, 1 up on you. Brady, you still with us? Oh no.
Maybe not.
Mr. Parks.
Someone else is here.
Oh, he's here.
He's here.
The man is here. Other people probably join eventually. But anyway, happy Earth Day, folks. We're going to get started. So, last time we met, we were talking about what a glacier was and how it forms and just some cool stuff that goes along with it, talking about paleoclimate, or in other words, looking at some of the things that have happened in the past that can tell us what the climate was like. So we had mentioned that there were those scratches in some of the rock, and that was formed from a glacier that went over that area. And so the area in that picture was no longer covered in snow and ice, and that means in the past it must have been really, really cold. So pretty cool that we can see some leftover marks and things that tell us, okay, at some point there was a glacier here. Nothing else is going to leave behind these huge scratches that are going to tear up the earth. Had to have been from a glacier, so it had to have been cold enough for a glacier to exist. So really cool that you can do that, as well as going into a glacier itself currently and getting some of the air pockets out of it that have been stuck there for hundreds of years, even thousands. And you can see what the air was like, so they can date that back using some of the different oxygen molecules that are in there. There are some different ones, and you can actually see like how rainy it was, how much ice had formed. So it's really, really cool that glaciers tell us so much about the past.
Hi, Ryan. We see you.
Oh, we do have another one. Hey. Another person with great attendance. But anyway, folks, that's what we're coming to today, is more evidence that glaciers have been to places. We looked at like the really, really big ways you can find it, but there are some other ways that you can tell that a glacier has been in the area, and that's where we're starting right here. So, glacial sediments. Firstly, till. Glacial till is a common term used for the material that is brought to an area from a glacier. It is angular, which means it was broken off and didn't go through that long process of weathering. It's not all nice and rounded out. Think about the sugar cubes, right? After a while of shaking them, they got nice and round. These are freshly broken. So they are angular and they're unsorted, which means that it's just all sorts of different types just in a giant heap. And so that could be anything from clays to boulders. So you just get this kind of mix of all sorts of random stuff just plopped in an area. And that is definitely something that you'll see with glaciers. On top of that, we also have erratics, which are basically just really, really big rocks, right? They're boulders that end up in an area, and the big thing that makes them an erratic and not just any old boulder is that they are a totally different rock than what you would expect from the area. So if you have this whole area that seems to be one type of rock, and you identify this huge boulder that you're wondering how it got here, and it's totally different than anything in the surrounding area, the only thing that makes sense is that something huge had to transport it here, and that huge thing is a glacier. So Long Island definitely has a lot of erratics. We'll show you one in a picture very soon, but it has to be different. And there's also a really funny clip that we'll we'll let you find the link for that shows this. Lastly, we've got outwash, which is from the toe of the glacier where it is constantly melting. Right? There's always some kind of little stream. Any of the rock material that's deposited from those streams we call outwash. It's washing out from the water that melts, and it does actually leave sorted material since it is water. We were playing with deposition with water before, looking at a lake, seeing, oh, the big stuff drops first, then like the smaller stuff. You got the round stuff falls first, and then the flat stuff. So water definitely sorts things. That's very different than how a glacier just plows things into a pile, and they're all very different. But in front of that glacier, where you do have the running water, where it's melting, you will find that layered, sorted material. So what's cool about all this stuff is this is all stuff that's on Long Island. You can find outwash plains, you can find erratics out in the woods, and definitely if you've been to any of the North Shore beaches, tons of till. And again, we'll show you some pictures, but Long Island is glacial. It was made from glacial material. So all of these things are things that if you went out, if you go out into the woods, or if you're like digging somewhere, you're gonna find evidence that a glacier was certainly here. So here is a clip. It's from a cartoon called Clarence. Funny enough, what was it, maybe like 2 years ago, I was talking about erratics, and a student raised his hand and said, oh, you're talking about, rocks from a glacier from somewhere else? That was on Clarence. I was like, what? There's cartoons talking about glacial erratics? That seemed so random. But totally true. You could look up this clip on YouTube. Clarence, A Pretty Good Day with a Girl, and it talks about exactly how erratics and these monster rocks, as they call them, get to where they're going, and how they just randomly find one in the woods. I thought it was hilarious that a cartoon would take such like a weird earth science detail and run with it, make a whole episode, but it exists. So you
it
may
does.
Yeah.
It's a funny one. I would recommend you guys watch it if you haven't seen it.
Absolutely.
That episode.
But it's all about glaciers and this monster rock that they find, so give it a look afterwards, the lesson. Not the best picture of glacial till in the world, but this is from Long Island. This is from, again, the North Shore, and you can see that, or hopefully you can see, that there are all of these cobbles mixed in with sand, mixed in with all different sizes. So this is that glacial till that is part of that bank of the hill that's at the beach. So definitely evidence that there was a glacier here. You'll also know, if you've been to North Shore and South Shore beaches, North Shore beaches tend to be very, very rocky. The reason being is because the till makes up the North Shore, whereas for the South Shore beaches, they are made up of a lot of outwash plains where you had all of the materials sorted. So you'll find that the South Shore beaches tend to have a lot of that like nice fine sand, whereas the North Shore beaches have all these big cobbles and some boulders and things. So that is the reason that North Shore beaches are rockier than the South Shore beaches. Clarence, cartoons do that. Yeah, they do. Cartoons just find some weird stuff and just kind of run with it. But definitely take a look at that episode on YouTube. So here's another really blurry picture, but these are the best things we could find. And the Port Jeff erratic. In Port Jeff, there is this huge boulder, and it again isn't like the surrounding rock or what you would expect. It's somewhere. Or it originally came from somewhere probably in the Sound or Connecticut, but it is this enormous boulder that was so big and so strong that instead of breaking it, they decided to just put a parking lot around it. since it would probably cost them a lot to excavate and move it, and what do you do with it? So they just left it. So if you're ever going down, I believe it's right on the, if you're going north on, what is that, 112, eventually you come down to like a hill, and then on the right hand side there's this huge boulder. So that's where it is, right in Port Jeff, if you're heading towards the Sound. So that brings us to some of the bigger formations of glaciers, one of them being the moraines, which are these giant, you could think of kind of like mounds of this glacial till that just get deposited. You could also think of it like if you're at the beach and you took your hand and you pushed, right? You just pushed along the top of the sand and you made like a little bump. That's what a glacier does. It moves over the land and it scours and it pushes all the sediment with it, and it'll eventually leave this berm, right? This big pile of just random stuff. That is what we call a moraine. And there's two types. There's the type that goes with the glacier until it stops moving, and then there's also ones that, as it kind of goes back and forth between building up and then melting again, it can make smaller mounds. So we've got terminal ones and we've got recessional ones, and we'll see on Long Island we have both, which is pretty cool. One thing I don't think we have on Long Island are drumlins, though, and these are these big hills. They're kind of teardrop shaped, and they could be, like 50 feet tall or so, and they form underneath the glacier, and they can actually show which way it was moving. So there was a buildup of sediment, it went over it, and it kind of drags it out, and it just went over and did not move the rest of it. So you get these drumlins forming. Pretty weird shape, looked kind of alien, honestly.
Almost looks like it could be like some sort of creature under there.
That's true too, yeah. Looks like something's trying to like burrow out or like lift itself out. But yeah, we don't really have too many drumlins. We have more like the moraines. So here are the different moraines that are on Long Island. You've got the Harbor Hills over here. You've got that going into the Roanoke moraine, and then the Ronkonkoma moraine. So this would be that terminal moraine. This is where most people are arguing that the glacier went to its maximum. So this is as far south as the glacier ever went, that time ago. And then this one here, this purple into green, would be that recessional moraine, where it advanced again a little bit and then ended up melting, because as you guys know, right now we don't have glaciers that exist on Long Island or in Connecticut or Maine, right? It receded all the way back and melted. So there are still some mysteries to this, though. I've read a couple research papers that argue that they've found remnants of a third one that go out past the Ronkonkoma moraine. There's some interesting features over here with this odd pile of sediment that stretches below the Ronkonkoma moraine. So there's still work to be done in earth science and figuring out what our past really was. So they feel pretty strongly about the Ronkonkoma, but there are certainly some odd pieces of evidence that make people turn their heads. They found a couple erratics that made their way south of this moraine, those giant boulders, and they're wondering, like, well, how did those get there if the glacier never actually made it there? So definitely some things to study. Imagine getting run over by a glacier. Well, it's not very fast, but boy, if you just let it go over you,
there wouldn't be much of you left.
it'd be like that scene from Austin Powers. I don't know if you know what I'm talking about. Or
I
like
do.
The steamrollers coming, the guy's just screaming for like an hour. Oh gosh. Well, anyway, yeah, getting run over by a glacier wouldn't be fun. I used to think of glaciers like fast, but yeah, no, they're only moving, at most a meter or two a day, and that would be moving fast. Yeah, they are powerful though. All right, that brings us to a couple other things that exist on Long Island. You can find two of these pretty easily. The other one's not so much, but we've got these eskers, which are when there are rivers that run underneath a glacier, they make these kind of cool snaking sediment patterns. Kames, which are just big sand deposits that would be next to a glacier. I'll show you that in a picture. But then two things that we definitely can find on Long Island are kettle lakes and outwash plains. So a kettle lake is pretty different than a regular lake. You've got a giant chunk of ice that breaks off from a melting glacier, and it finds itself in loose sediment. And so you've got this heavy piece of ice that's sitting on top of sand, and over time that sand will probably get a little lower. It'll sink from all the pressure, and also sand will probably build up on top of this piece of ice, especially if it's not warm enough to totally melt that giant chunk. So what'll happen is over time it'll get buried, and it'll take up space underneath the, like where you would think the ground line is. So this is almost like when you have acid deposition. You've got like acid rain that makes like a sinkhole. You've got this thing that is taking up part of the ground, and eventually it will go away. So what does it leave? It leaves a cavity in the ground, and that's how you get what we call a kettle hole. And if that interacts with the water table, if the water's high enough, well, it'll fill in with water and it'll make a lake. So these things can be pretty deep. That's the interesting part about them, is that if this giant chunk of ice was really, really big, you can get lakes that are, instead of 20 or 30 feet, you can get something like what we have with Lake Ronkonkoma, which is one of these kettle lakes, and it's, if I'm not mistaken, I think it's like 60 feet deep, like pretty instantly.
I think so. Right in the center, I think, is where it reaches that point.
When in doubt, fact check yourself. Lake Ronkonkoma depth, 65 feet. Most of the lake is less than 15, but it does reach pretty deep, 65 feet. So that is uncommon for a regular lake to be that deep. I mean, if you're in a boat like in the Sound, like usually you're like 40 feet. I mean, it goes down pretty deep, but like if you're close by, so this is pretty deep. Remember those lakes we were talking about that I live near? The ones that were just, I forget the reason, but we had a full-blown conversation about them. Not quite. The lakes we were talking about that I live near. The ones that were... Was it a conversation all of us had? I don't quite remember about the lakes you were talking about. Can you fish in the lake? Lake Ronkonkoma, I think it's kind of... Well, some people fish there, I think.
I think you can, but I don't think it's really recommended. There always seems to be problems every year with algae, just because it's not a freshly flowing body of water.
Yeah.
So there seems to be...
Right, any pollution that's going to get into that is going to just stay there, since it doesn't even seem like it has any outflow. Right?
Yeah, I know every year. You can swim in it, but usually they tell you not to after a while once you get into the summer season.
Yeah, not quite sure. Not quite sure what fence or lakes we were talking about. We were talking about the Finger Lakes, Great Lakes.
The ones I
totally forget. Sorry, it's been a while.
You have to tell us where you lived, Ryan, and then maybe that would help us.
Well, if you can remember, you could always pop into office hours later and strike up a conversation.
Yeah, definitely. We can do that.
So, here is a picture showing some of those different features, right? The esker being that like snake sediment deposit. You've got the kettle lakes, which are those giant hunks of ice that leave these depressions. You got the drumlins. You got your outwash plain where these rivers flow past and leave behind the sorted sediment, as opposed to the till, which would be in this giant mound here. This mound would be made up of till, the very randomized sediment. So glaciers do leave behind a lot of kind of these cool footprints of different things. Outwash plains are a little hard to know that they were glacial if you're just looking at them on their own, but if you see that there is till surrounding it, and you can see kettle lakes or any of these other different little features, it gives you an idea that that's where the glacier had ended. So kind of cool. A lot of little of these features give you a lot of ideas about the past. So here is a picture of Long Island, and these are all elevations, green being low and then going up to like that red, which would be like high elevation, and you can see the moraines nice and clear, right? The terminal one and then the recessional. And there are also a lot of weird, funky features. In college, I was looking at this feature here particularly because I live very, very close to it, and it's complex. There's a lot of things going on, and again, there's a lot of things that we don't exactly know. You could see here that it's mostly green towards the south, and you can see it's flat, and it has some of these little streams that go through. This is that outwash plain. Again, we said that the South Shore is mostly outwash plain, so you get like those really, really sandy, nice beaches, whereas you can see a lot of the elevation, those moraines, are up towards the north. And again, that's why you get those rocky beaches.
Yep, that's why it's also flatter in the south and you have more of the hills in the north.
Absolutely. If you've ever, been between the two areas, you'll know that it's very different in terms of like even the streets. The streets are very grid-like in the south. Everything is easy to organize because it's so flat. And in the north, you've got crazy roads going up and down and all sorts of different town plans. And that's just, good point. It's a response to the environment that they built their towns in. There's also some really, really crazy hills that you'll drive on and all of a sudden like lose your stomach if you aren't really paying attention up in the north. Some crazy roads. But yeah, I like this image. It's very interesting to see that actual difference, like in reality, like where the elevations are different, and it just kind of explains all the things that you might be living around and not really thinking about. Oh, reservoirs. That's what you're talking about. Sorry, going back to the point you were making before about the lakes you were talking about. What about reservoirs? Reservoirs are pretty cool. Mostly a man-made thing, though. Bricks of a glacier.
Now it makes sense.
Yeah. Right, because they can dam that area, and then it builds up and it makes the lake, which is the reservoir. Yep. Yes. Yeah, there's certainly a bunch of different lakes that we can specifically attribute to being glacial in origin. I don't know Argyle Lake. Do you know that one?
I don't know about that one, Ryan.
I don't know that one specifically.
We would have to look that one up. I don't know if that's man-made or not.
Argyle.
It's in Babylon.
I don't know. formed by a dam across Carl's River. So that seems to be a man-made one.
Yeah.
Maximum depth, 4 feet. Pretty shallow. But it is stocked with different fish, so I imagine that you've gone there probably to fish.
It's like a big picture taking place. It's got like a, scenic.
Sounds nice.
It is nice.
Oh yeah, look at that. That's a really nice place. It's pretty shallow though, 4 feet. That's cool. Yeah, looks like a really nice place. Huh. That's funny. Alright, folks. Well, that's pretty much it for what we wanted to talk about. Just a little bit on Long Island and, some of the features that you can actually go out and see.
You might notice some more now when you go to certain places that you'll be able to say, you can identify them.
Once we get through rocks and minerals, you might actually be able to say something about erratics. But usually if you see a big boulder around here, it had to have been a glacial erratic. Unless it's something that was brought over by people. But that's expensive and not usual.
Right, not the landscaping kind of boulders, but just boulders kind of in a place where they shouldn't be.
Yeah. Although some places that do, like big houses or anything that have cool rocks on their property, those are usually excavated from the area and they just keep them there, but you never know. Anyway, folks, don't forget that we have our office hours again. 12:40. No, just kidding. Oh wait, no, that is right. 12:45 to 1:30, and 1:30 to 2:15. Any work coming soon? We usually post work at sometime around 2-3 o'clock. So, stay posted. Sometimes it comes out earlier, sometimes it doesn't.
Yeah, anything posted today is not due until Monday, so you have a good bit of time to do it.
Yep. Always remember that. Wednesday assignments are due Monday. Monday assignments are due Wednesday. Very simple. Also, we do have our social hours on Friday. I forget. For this class, I think, for both classes, it's 2 to 3 and 3 to 4. I think for each different class. So, if you want to just stop by, say hello, see who's hopping on, that might be fun. See some faces. But other than that, folks, that's what we got for you today. So, see you in office hours.
Yeah, we'll see you later, maybe. Have a good one.